Hi, I'm Ashwini, and this is Greenstock, an inventory assistant built for organizations like nonprofits, cafes, and university labs. And I'll walk through the design, a live demo of the features on this, and then the AI layer with its fallback system. So the I'm gonna go to the tech stack and the design. The back end is Fast API with Python and SQLite. I chose SQLite because small organizations shouldn't need to manage a Postgres server, and Pydantic handles all input validation. And the front end is React with Vite. No component library, just Tailwind utility classes. And um, let's see. The AI layer calls Claude Sonnet via the Anthropic API for two features, smart item categorization and usage forecasting. And the key design decision was fallback first. The rule-based answer is always computed before Claude is even called. So if the API is down, there's a timeout, or if credits run out, the app keeps working. And users see a badge telling them which mode they're in, whether it's using AI or the fallback. And that transparency was intentional. So the app itself, this is the main dashboard. It shows the total item count and how many are in critical condition or low stock, and then things that are expiring soon. And then status is computed automatically at read time, no manual flagging is needed. And now we can look at the inventory list. The inventory list shows all items with their current status, so you can see if it's expired or if it's okay. And I can search by name. So if I type in coffee, you can see coffee beans. And I can filter by category too, so I can see like chemicals or lab consumables. Yeah, and status badges update in real time based on quantity versus reorder threshold. And so I can like click on the item and log any usage, but also, yeah, I can see all of the items information like the category, stock, expire date, and eco score. And so basically I can add a new item, and I'll type in nitrile gloves as the name. And normally this is the AI fill button, is the first AI feature. It sends the item name to Claude, which responds with a suggested category, reorder threshold, and sustainability score with reasoning. When the API is available, you'd see it populate these fields automatically with an AI badge confirming Claude responded. Right now, you can see the fallback badge. The keyword matcher has recognized gloves as lab consumables and suggested the threshold of 3. And this is exactly the graceful degradation the system is designed for. The user experience doesn't break, it just degrades to rule-based logic. And I can just put a quantity. I'll just put 50 units, and then I'll just put a random expiry date. And yeah, you can see that the new item appears in the list with the correct status, which is okay. And normally I can also click this button for any item to see a prediction. So this is how the system tracks consumption over time. Let's see. I can also edit the item, any item. Okay, let me log some usage against this item to see how it tracks consumption over time. So I will log that we used 10 units today, and this is for the canned kidney beans, and the system deducts from the current quantity and records a time-stamped log entry. So if I now click on, so it automatically updated, and yeah, so you can see the AI forecast says it's low stock and it'll run out if the usage is 10 units again. So now I showed you the forecast feature. Clicking the forecast button on any item calls the second AI feature. When Claude is available, it receives the last 30 days of usage logs and returns a natural language prediction about when the item will run out and whether to reorder. Again, we're seeing the fallback badge here. The rule-based forecaster is doing a linear projection. It takes the rolling daily usage rate and projects days until stock out. And when Claude is available, we can go back to the kidney beans. When Claude is available, the same data gets sent to the API and comes back as a human readable summary. Like at current usage rates, this item will run out in approximately 12 days. Consider reordering from an eco-certified supplier or some message like that. Okay, now I can show you, I can try submitting something with no name, so I can select a category, current quantity, I'll just do like 28, and I'll try submitting it. And validation is handled at the API boundary by Pydantic. Submitting without a name with a negative quantity or an eco score outside 0 to 100 returns 422 immediately before anything touches the database. And I can also edit any of the existing items as I showed you before. Okay, and now I can show you that I have 32 tests that I had written. And one sec. Let me run them now. And all of them have passed. And they're happy paths for all CRUD operations, validation, edge cases, status computation, and AI fallback behavior all passing. One interesting challenge was the SQLite threading. Fast API runs sync handlers in a thread pool, and SQLite connections aren't thread safe by default. So I solved it with check same thread is false and switch the test suite from in-memory SQLite to per test temporary files, which is actually the more robust approach anyway. And three takeaways. First, fallback first AI design makes the product shippable so you're not dependent on the API being up. And second, SQLite threading model is subtle and the fix isn't obvious. And third, Pydantic at the boundary catches bad data before it ever reaches the database. So that's Greenstock. It's a full stack inventory management application with AI categorization and forecasting with fallback and a solid test suite. So thank you for watching.